Hello there and welcome to Lower 6th Further Maths A-Level. This is the core part of the syllabus. We're on the sample assessment material. Here we're on question 7. Question 7 gives us a bird bath with the measurements shown. The equation of the dip part is modelled by y plus 1. So y equals 1 plus kx squared in between 0.2 to minus 0.2. Height of the bird bath is 1.16. Diameter of the bird bath is 0.4. Suggest the maximum depth of the bird bath. So that's the maximum depth that is here. Well, 1.16 take away whatever this is. And as it's modelled by this equation here, it's when x equals 0. So in the equation here, y is just going to equal 1. So therefore the depth here is going to be 1.16. Take away 1. Because we have a coordinate of 1 up here, and that's just going to be 0.16 meters. Okay, state the value for k. Well, let's work with this coordinate up here now. This length of the maximum height on the corner of the bird bath is 1.16, and this is going to be when the x-axis coordinate is 0.2. So we need to square that. So 1.16 equals 1 plus 0.04k. Take away your 1 from both sides, and you've got 0.04k. Divide through by your 0.04, and you get k is 4. So the equation that we're dealing with here now is 1 plus 4x squared. Alright then, so for part C, it is time to now work out the volume of this bird bath. Now, what we're going to do here is we're going to be working out the volume that's around this y-axis. So we're going to be working with y-coordinates here, so just a reminder, that y-coordinate there is 1, this y-coordinate here is 1.16. And seeing as we're revolving around the y-axis, we're going to be using this curve to do so, this curved line here, which means that when this revolves around the y-axis, actually what we're going to be working out is all of this volume here. So that's not much use to us. In fact, the inverse of this is useful to us. So what we're going to be doing here is we're going to be working out the volume of a cylinder, which this thing here will represent once it's revolved round. Take away the area that we get once we've integrated this equation here. The formula that we're going to use for this is pi times the integral from 1 up to 1.16 of x squared dy. So that's the formula that we use for revolutions around the y-axis. In this case here, it's going to be y minus 1 over 4 equals x squared. So that's what we're going to be integrating. So pulling the divide by 4 out to the front, we're going to get 1.16 down to 1 of y minus 1 dy. This part here is easy to integrate, so we'll just do it straight away. Y squared over 2 minus y, that's from 1.16 down to 1. So this is going to be equal to pi by 4, and then what we do is we substitute in the higher bound and we take away the lower bound. So 1.16 squared over 2 minus 1.16. Pi by 4 needs to times by all of this, so I'll leave that right until the end. And then it's going to be 1 squared over 2 minus 1. Okay, so work out what this calculation here is, and that will be the red area that we've calculated there. So grab your calculator, work that out, and what you end up with is, we'll leave it in terms of pi for now, 0.0032 pi. The cylinder here, well, the cylinder is equal to, cylinder formula is the area of the top part, so that's just going to be pi times 0.2 squared times by the height of the cylinder, which is 1.16, and for that we're going to get 0.0464 pi, and then quite simply for the volume of the bird bath is going to be equal to the cylinder, 0.0464 pi, take away 0.0032 pi, and to three significant figures it's 0.136 meters cubed. Perfect. Okay, part D is stating limitations in your model. So the measurements may not be accurate, the inside surface of the bowl may not be smooth, there may be wastage of concrete when making the bird bath, anything like that. It is later discovered that the volume of concrete used in the bird bath was 0.127. So what did we do? 0.136 meters cubed we used in comparison to that. Use this information, evaluate your model, explaining why. Okay, so for part E, the model overestimated the amount of concrete used okay, so yeah, that's pretty much what you need for question 7. Alright, 12 marks in total for that.